Hi everyone, welcome back to the channel. In this video we are going to learn about XS3 code. I will explain what it is, how it is different from 8421 BCD, and what are the similarities between both of them, and what are the other names of XS3 codes, and its applications. So how to add XS3 code to a normal binary digit, and two numbers has to be added with the XS3 code as the final output. So we will see some of the 5 examples, or I will explain 5 examples, so that you can able to understand, or you can able to do further with your own self. So here you can see the 8421 BCD. So we already saw the BCD means binary coded decimal. So we know how to represent that 0 as that for in binary format. So we also know that positions corresponding 8421 is the binary positions. So if you observe 9, so if you add 8 plus 1 in the positions, you have to put 1. So that is 1001. So similarly we can fill all the digits. So that is binary coded decimal BCD. I have understood BCD so up to now. So then what is meant by XS3 code? So XS3 code means nothing but we have to add for each and every bit of there by 3, that is in binary, that is 0011. So after adding each and every bit we are going to get, so suppose if you take 0, so if we are adding 3, so output we are going to get 3 only. So likewise if we add 1, so 2 3 we are going to get 4. So fill all. So that is the our XS3 code. It is nothing but adding 3 to all digits, that's it, in binary. So if you observe one common point in this, so if you observe any two consecutive bits, so suppose if you go from 0 to 1, so how we are going from 0 to 1, that is if you are adding 1, then you can go from 0 to 1. So if you are going from 2 to 3, so if you add 1 to 3, you are going to 4. Likewise if you add any bit to that bit, you are going to get the consecutive bit. So similarly in the XS3 code also, if you add 1 to the first bit, 0 bit, you are going to get the first bit. So likewise if you add 2 to 1, you are going to get the corresponding bit, XS3 code. So that is the similarity between 8421 BCD and XS3 codes. So already we have XS3 code in the classification previous video. So here we have to classify this XS3 code into non-weighted code, because here weight does not matters. So if you see the 8421 BCD, those are weights. So weights corresponding to position, we are placing that. Suppose if you take 9, so 8 plus 1, that is corresponding positions, you have to put 1. But in non-weighted codes we have we have no weights, so we have no corresponding positions. So if add 3, that we are going to get corresponding XS3. So it is known as non-weighted code. So it is a sequential code also. Why? Because if you add 1 bit, so you are going to next bit. So likewise if you are going to add 1 to the 2, you are going to 3, that is in XS3 only, in a sequence. So it is sequence code. So if you observe, it is also called self-complementing code. Why? So we have already saw in the classification video. So but in a brief we will be going to see here what is meant by self-complementing code also. So in this we want the 9's complement of n. So what is meant by 9's complement of n? So the formula is nothing but 9 minus n. So in the place of 0, so you are going to just subtract 9 minus that variable, that is n, 0. 9 minus 0 is 0. 9 minus 1 is 8. So last one is 9 minus 9 is 0. So I am going to get, I have highlighted it in the blue color as well, that is the complementing 9's complement of n for the decimal from 0 to 9. Similarly, if you observe in the XS3 code also, so what is meant by XS3 code I have discussed earlier only. So if you add 3 to the normal BCD, so you are going to get XS3 code. So in the XS3 code also, if you see the 0 and 9, so if you just complement the 0, you are going to get 9. So complement means, so 0011. So you have to invert zeros with ones, ones with zeros. So after inverting, so it is similar to 9. So let's check 0011. So if you invert both of them, so 1100, so we can say that 0 is complementing with 9. The similar thing we can see in the decimal as well. So that is why this is known as self-complementing code. So these two are examples of self-complementing code, XS3 code and BCD code. So I hope you understood what is meant by self-complementing code. So let's read some definition, that is XS3 code is the only unweighted code which is self-complementary. Yeah, it's a true definition. So basically, we have three properties in a single type of representation of unweighted code, non-weighted code in a numeric code, that is XS3 code, unweighted as well as self-complementing in one code. Let's start the additions process. So how to get XS3 code or XS3 output? So let's start with the first example, that is if you are going to add a normal single decimal 2 to 3, that is we are going to get 5, that is XS3. So why this is known as XS3? So because the output is accessed by 3, so that is known as XS3. So similarly, if you convert to binary in that form, so if you convert 2 to binary, that is 0 0 1 0. So if you are going to add 3 in binary, that is 0 0 1 1. So we are going to get 5 as output, that is 0 1 0 1. Let's see the second example also. The second example is 24. So as you're seeing there, it is normal, not like normal one. So XS3 code has to be done in a separate manner. So let's see the separate process for doing this, adding 3 XS3 to the 24. So as you're seeing there, we have to add 3 to individuals. So 2 is added with 3 and 4 is also added with 3. So we are going to get 5 and 7. So 24 is XS3 is 57. So you might think, so XS3 means you have to add to whole. No, we should not add to whole. That is, we should not add 24 plus 3, that is 27. No, that's wrong. We have to add an individual digits to 3. That is, we are going to get final output, that is 57 as shown there. So the same 24, if you add in binary also, so that is we have to go into separate or drag 2 and 4 separately. That is in binary, that is 0 0 1 0, that is 4 in 0 1 0 0. So we have to add 3 separately. So 2 plus 3 5 and 4 plus 3, that is 7. We have to add separately and we have to take the outputs that in binary also separately. That is our final output. So that is final output is 0 1 0 1 and 0 triple 1. We have to write combinedly as the output. You are seeing there, that is the first addition, that is 5. The second addition, that is 4 plus 3, that is we are going to 7. So in the normal addition also, like in XS3, we are getting 57. In the binary addition also, we are getting like 5 7 in binary. So the second representation is also correct, that is in binary, that is 0 1 0 0 1 0 0. That is in XS3, that is 0 1 0 1 0 triple 1. That is same as 5 7. So we are going to add in this way only to get XS3. We should not add 24 plus 3 gives you 27. So don't think in normal binary format. So we are not going to convert that 24 into binary, whole binary, and we are going to add that whole binary 24 to simply 3. No, that's not the true manner. So in this process only we have to continue all the process. If 3 are there, if suppose 24, in the place of 24 we have 526. So we are going to add 3 to individual digits and we are going to mess up. So that is our final output. So that is only, so let's see that example also in the next example. Let's check out this example also, the third example, that is 6 5 8. So as I said, we have to separate the 6 5 8 separately. So we have to add individual digits with 3, that is 6 plus 3, 5 plus 3, 8 plus 3. I hope you know how to write the 6 in decimal to binary or binary to decimal. If you don't know, you can check out our previous videos that I am giving in the description box. So after adding 6 plus 3, we are going to 9. So 5 plus 3, we are going to get 8. So 8 plus 3, we are going to get 11. So that is the correct method only. So we have to mess up that 9, 8, 11. That is the final output. So you can see the final representation of the output. So the output is, so basically we are getting the 6, that is 0 1 1 0. So I have separated the 4 bits as you're seeing that in red highlighted way. So that is 5. The second part is 5, that is 0 1 0 1. So the last part is 8, that is 1 0 0. I have, that is 3 separated. So the XS3 is just the combination of the outputs, that is 9, that is 1 0 0 1, that is 8, next one, that is 1 0 0. The next highlighted black is 1 0 1 1, that is the XS3 code of 658. So we have in the decimal form also, that is 658. The XS3 code is 9811. So as you seeing the up to now, we have discussed those 3 types of XS3 codes or XS3 we are adding to those three examples, that is a single numbered values. So next two examples we are going to discuss the addition part. So it's not 2 5, that is in the between we have addition operator. So we need to find the XS3 code of double numbered sum. That whole number, that whole 2 plus 5, we have to add 2, we have to take 2 times the XS3 code and we have to separate 1 time XS3. So let's see why we have to separate one time XS3, because let's see. Take an example. So in this case I am taking 2 plus 5. So you know how to represent 2, that is 0 0 1 0. So if you add 3, so you are going to get 5, that is 0 1 0 1. So if you take 5, that is if you are going to add 3, you are going to get 8. So in the general case, if that is given as 25 or 25, so we have just to combine those two outputs and we have to write the output, that is the final output. So in this case they have given a plus operator in between, that is 2 plus 5. So we have to going to add those two outputs. So in because of they have given plus operator, we are going to add the two outputs. So or two XS3 codes, we can say simply. So I hope you know how to add binary digits. So after adding we can get that is 1101. So is this the final answer? No. Why? So we are adding the 2 times the XS3. So we have given now got the XS6, not XS3, because if you observe clearly, we have already added extra 3 in the 2 and extra 3 in the as 5. So both times we are adding, so that is double counting, so that is XS6 we are getting output. As I said, that is XS3, that is 1101. So we have to subtract 1 minus 3. After subtracting, so we are going to get 1010, that is 10 in decimal. So this is the XS3 code that we are waiting for, because the previous one, that is 1101, so that is XS6. So we are accessed with extra 3, we are accessed with extra 3 plus extra 3. So we are going to subtract 1 3, so we are going to get the final answer, so that is 10. We can also check the normal method. So there we have 2 plus 5. So as the previous method says, so we have to add separately with 3. So after adding separately 3, we are going to get first one as 5, the second one as 8. So as I said before, we are going to add both of them. So after adding, we are going to get 13, that is XS6. So we have to rid of 3. So we are going to subtract 13 minus 3. So the final answer is 10. As we saw in the previous slide also, that is 10. So this is also 10. So this is the XS3 that we are required. I think this was the one of the means up to now what we saw. It is somewhat easy. The fifth example is somewhat tough, somewhat difficult, as I can say. Why? Why? Because it is involving two concepts. We have to add. We have to, that is plus operator is there in between. So two digits is there separately. So let's see how to solve this one. So that is 27 plus 39. So I hope you know how to write the 2 and 7. So we have to represent separately, not the 27 in the decimal form directly. The decimal form of 27 should not be represented directly in the form of binary. So it has to be splitted. So there we have to consider 2 digits, that is 2 7. So we have to the first 4 digits belongs to 2 and the next 4 digits belongs to 7. So you know how to represent 7, that is 0 1 1 1. So 2 0 1 0. So you have to add separately plus 3 to the 4 bits. So after adding, so you're going to get the output. So that is the output of the first one, that is 27. So that is output is 0 1 0 1 1 0 1 0. So the second one is 39. So 39 also the same procedure. So 3 should be represented separately in 4 bit and the 9 should be represented separately in 4 bit. So the 3 is 00 11. So the 9 is 1001. So we have to add separately the 4 bit with 3. So after adding that XS3 code, that is 0110, so 1100. So in between we have given a plus operator. So according to the previous problem also, so we have to add the two outputs or the two XS3 codes. So I have separated as two groups. So in the first group addition, so I am getting 0110. So I am getting a carry. So I have represented the carry with a red highlighted way. So the group 1 with a carry 1. So the second group also, that is with a carry 0. So because we are getting double 1 double 0 and the final carry is 0 for the second group. As you're seeing there, we are getting XS6. So after adding the both of the XS3 codes, so finally we are going to getting XS6 as the previous problem only, like fourth question. So what's the difference? Why we are noting down the group 1 and group 2, and why we are noting down the carries of 0 and 1? So is this important of noting? Yeah, it is very important to note the final carries, because in this problem we are not having a single group, so we are having two sets. So we should not subtract directly minus 3 from the both groups. So we are going to subtract when the carry is 0. We are going to add when the carry is 1. So the first group carry is 1, so we are going to add 3. For the second group the carry is 0, so we are going to subtract 3. So that becomes our final answer, not this. So we are not going to subtract 3 from the both of them. That's the main thing of this XS3 code. So that makes this problem somewhat tricky. As we noted that the carry of first group is 1, so we have to add 3. So the previous output, if we consider, that is double 1 double 0, so we have to add 3. So I am adding 3 to that. So the final output that we are getting is 1 0 0 1. So the second group that we are getting as double 1 double 0, so the carry is 0, so we have to subtract 3 from it. So after subtracting 3 from it, so we are going to get 1 double 0 1 as output. So combine both of them, that is our final output. After combining, you can see like that, that is the final output, that is 1 double 0 1 1 double 0 1, that is 9 and 9. So this is our final XS3 code. So we should not directly subtract from both of the groups. So according to the carry, we have to decide whether we have to subtract or whether we have to add from the XS6 code, so to get the XS3 code. Let's check this problem with the help of normal decimal addition also. So if you add both of them, 27 plus 39, so we are going to get 66. So as I said, 66 is a normal digit, a single digited value, so we can get simple XS3 code. So that is so that is like first example, the second example only. So add 3 to individual digits, so we are going to get 9 nines separately. So combine both of them, that is our final output, so that is 99. So hence verified with the previous example also. We are in the previous in the previous question also, in the previous slide also, we are going to get 9 so in binary format, that is same, hence verified in decimal format, in binary format as well. So these are the overview of the things that we have discussed in this session. So that is 2 is converted with XS3, 24 is converted XS3, 658, 2 plus 5, 27 plus 39. So these are the things converted. If you don't understand, please recheck once the video. So these are the overview. So I hope you understood all. If you don't understand, let comment down below. I will reply to you. If you understood, so these are the questions, same questions, try your own, so that you can able to understand. These are the basic examples that you can try by your own by converting these to XS3 codes. Thanks for watching up to now.